Right, ready? Okay. It's okay. I was late, so I cannot. Sorry? Yeah, yeah. Folks on the call, can you able to hear me now? At least one person act from the call will be useful. Nobody's hacking.
Still on mute, or maybe they don't know. The volume up.
I
think I muted everyone.
If I talk, I think I can see this thing coming up, right? Or is it coming? Yeah, I can see Kyle Mystery talking, so should be.
Yeah. We should be good.
You're okay? All right.
Oh yeah, we can hear you. Someone just typed that. Yeah.
Okay. And my mouse is not anywhere. Oh my God, what's going on? Okay, there we go. All right, it's slow, but it will work. Okay, so this is a really impromptu thing for me to do a presentation here. So I have just one slide to show what we have done in the OpenDaylight project, working with OVS DB and OpenFlow. It's entirely on OVS. I will cover a high-level picture on what we have done, and then we'll go to a small demo of the OpenStack integration itself, which will cover both OVS DB work, also the OpenFlow 1.3 work that we did with most of them here, right? With Kyle, Thomas, Ashwin, we all work together to make it work. And on the call, I think Brent is also there, and Dave. They're all there. I have the chat as well. Small team that we worked, made it happen. So as you can look at this, the picture here, OpenDaylight is a modular architecture where we have it's Java-based plugin architecture using OSGI, where we have multiple plugins act in the same controller, in the same JVM. As you can see, the Neutron is an application of OpenDaylight, which uses the Northbound APIs. In this case, we use the Neutron Northbound APIs directly as the exposure to the Neutron plugin, M2 plugin. And we have an application called OVS DB Neutron application that is sitting in the middle, and my mouse cursor is not showing up. It's a blue box that is sitting in the middle, right next to the OpenDaylight picture there. The application here, which talks to the Northbound of the Neutron Northwest APIs, and it talks to the Southbound plugin, the OpenFlow plugin, also the OVS DB plugin, through the AD style and LD style. This another layer is called self-abstraction layer, which abstracts out the actual plugin that takes care of the southbound mechanism with the northbound applications. So it's kind of an abstraction layer that we have to abstract out the protocol information from the application requests, essentially, right? We are here. The OVS, the entire application of the OVS DB Neutron application is built with OVS as the edge. So we use both OVS DB as a mechanism to create tunnels, create ports, create bridges, so on and so forth. And we use OpenFlow for doing the actual flow programming. All using OVS, it works great for us, and that's what we do. Right? And we originally used 1.0, and then we migrated to 1.3. Both works reasonably well. I mean, we don't have any problems with 1.3 today. Just that 1.3 itself can do better, like have a better research, have better, for tunnels today we use the GRE key equal to flow we can do, but we cannot take the destination IP from the flow. Rather, we need to hard code the tunnel destination IP, because OpenFlow doesn't support dest IP equal to flow. Right? So, a few things that we want OpenFlow enough to add support. I'm sure that once we have it, then we can make OVS work for the way it is. Right? Because today we don't do any NXMs, we use only OXMs in OpenDaylight. We don't have the augmentation support where we can augment the OpenFlow 1.3.
I hope that somebody will get involved with in ONF to push that agenda, because that's probably the only way it will happen if someone represents that point of view.
Yeah, so we are talking to Dan Pitt directly. But as you said, right, it has to be a member company to push it hard. Right? And since we are not a member company, it's kind of getting complicated there.
Red Hat's not a member company? No. Okay. You need to talk to Chris about it.
Yeah. Yeah, so it's not a member company, so that's a bit of complexity there. But it's so as you said, right, it's so natural for us to ask for it because the OVS already has it and it makes sense, right? It really makes sense. Because of that issue, right, if you look at I'll show the demo, you'll see that if you have, say, 100 compute nodes in Neutron, you'll have 100 peer-to-peer tunnels established because you cannot have a dynamic way to just multiplex and demultiplex tunnels.
Okay.
Right? That's one problem that we're facing. But other than that, the implementation of 1.3 itself works really good with OVS, thanks to you guys, and the OVS DB is rock solid as well, as usual.
Great. So I have a question about this
Yeah.
drawing.
Yeah.
So is the OpenFlow 1.3 also makes use of OVSDB, right?
No.
Oh, okay.
It's the OVSDB plugin is a separate plugin, which is completely isolated from the OpenFlow plugin.
Right. I guess the way that the drawing looks like right now to me, that on the left side with the ADSAL, it looks like it uses OVSDB and OpenFlow 1.0, and on the MDSAL, it looks like it just uses OpenFlow 1.3.
I'm sorry. Yeah. It's my mistake. My picture is not that obvious. So if you look at the OpenDaylight architecture, the plugins that you see the bottom, the plugins have no interaction sideways. They don't interact at all. And even the north-south, the service that you see here, they are the services provided by the ADSAL for the applications, right? So the reason that we have ADSAL and MDSAL is because in OpenDaylight we implemented the MDSAL approach. The new approach that we are implementing now is Yang-based, where we can define Yang model for every protocol, essentially. So we have a Yang model for OpenDaylight today. Even though we don't talk Yang between the switch devices, we have a local Yang model which converts it into messages and so on and so forth, right? So we had the original ADSAL model which is not Yang-based, but MDSAL is Yang-based.
Okay.
That's why I separated them out to showcase that 1.3 is Yang-based approach, while 1.0 is not a Yang-based approach. So still we are working with OVSDB with no Yang, just pure raw JSON architecture and we're using as APIs.
Okay.
Right. Yeah. So there's no cross-pollination of every plugin is an independent entity on its own. But you will see that we use the OVSDB plugin to program the controller information. So we'll say that using OVSDB, you can set the controller tables. You set a controller table stating that we want to create a bridge, BR tunnel or whichever bridge you create. We automatically set the controller as the OpenDaylight. Since we are the same interface, we know exactly what to do. And as we set the control information, then OpenDaylight connects to the plugin, and from there OpenFlow starts working. Yeah.
What do you mean by Neutron application?
Well, OpenDaylight is a controller, right? So it's a controller. So it doesn't differentiate between Neutron or any other applications. To us, it's an application because anything talks via northbound APIs is an application for us, right? And OpenDaylight, we have this northbound API specifically written for Neutron, right? So as you can see here, Neutron list APIs, right? In fact, it borrows everything from Neutron actually. What is Neutron API you see for the user to call on the Neutron side? You see the exact same APIs here, bit small difference here and there, but almost the same, right? And Kyle and Ryan, they helped make this happen, right? So now we have a simple plugin now. The plugin is kind of takes from the Nova and Neutron and pass it along to the northbound API of OpenDaylight. So from OpenDaylight standpoint, it's an application.
But one thing worth pointing out too is that it's the Neutron interface, northbound APIs, but it's also been integrated with other.
Yeah, cloud stack. Yeah. So even though we use the Neutron northbound APIs here, cloud stack guys use the same APIs and started programming it. So now the OpenDaylight with this integration, end-to-end integration, works for both OpenStack and cloud stack. Right.
So,
Yeah.
so using the ML2 plugin is the intention that you would do like multiple mechanism drivers there, or
No, we have this OpenDaylight ML2 plugin, right? Kyle is the
Yeah,
author of it.
the intention for that was, so prior to ML2, which is Mark maybe poorly named, it's not good. But anyway, prior to that, if the plugin developer for Neutron wanted to write a plugin, they had to write not only the interactions with either their controller or their agent, but also the database, logic, and all this other stuff. So ML2, and not only that, but depending upon what types of networks they supported, there was code they had to write for that. So ML2 kind of abstracts all that logic away. There's a common database model. There's type drivers for the different types of networks as well. So it means you have to write a lot less code. Now the intent is also that you can share multiple mechanism drivers as well, and that's theoretically possible for this at the time. Yeah, exactly. For example, the OpenDaylight mechanism driver only supports networks of type VXLAN and GRE. It doesn't support VLAN right now. So if you
Now we
want
support
VLAN network, it will, but it doesn't in Hydrogen.
That is really, yeah.
So it's from the release version. So if you wanted to run Neutron with OpenDaylight, you could run the vSwitch mechanism driver if you wanted VLAN networks on some host in lieu of OpenDaylight. So OpenDaylight just wouldn't bind ports to those networks.
but can you create multi-segment networks?
You could. Now the support for that, you have to use provider networks and handle the bridging of the network somewhere else. Although that's something we'd like to do at some point in OpenDaylight. Yeah.
So OpenDaylight development for Neutron just started like 6 months back, right? But the OVSDB, so the reason I took this picture is the Neutron is an application of all this. When we developed OVSDB, we developed OVSDB as a separate entity just to talk open vSwitch with just from management point of view. But the Neutron came out to be the leading application that was making use of it. So it's kind of makes sense for us to put everything together.
So today, the OVSDB mechanism driver for the ML2 plugin supports what VXLAN and what else did you say?
GRE.
And VLAN.
VLAN.
Provider network basically. And
Yeah. I mean, for the Hydrogen release, we supported only GRE and VXLAN, at least in OpenDaylight. We didn't support the VLAN, right? Now we are adding support for VLAN.
Provider network.
Yeah. So this is a high-level picture of what we have developed with Hydrogen. So I can show the code quickly, but before that, what I do is, why is this here? Okay, let me search something and it'll go away. Thank you. All right. So before I do that, right, let me start the dev stack. Dev stack takes time to come up. So let me start the dev stack. I have a dev stack set up running in my system here, and I work for Red Hat, so I use Fedora. So, and I know we all use Ubuntu here. Right, so. All right, I can do a stack.
It might be good to just, while you do that, give people a picture of what the pieces are here. So.
Sure. Yeah, okay, I'll go to the board then, because I don't have a pretty picture or anything.
Maybe you can use that whiteboard.
Sorry?
I don't know if you can use this thing maybe.
Is there a pen?
There's markers somewhere around here.
Yes, I think it's perfect. Thanks. So I have a really simple setup in my laptop, which I'm going to showcase here. So I have essentially I have 3 VMs in my case. This VM is they're running dev stack now. These two are running dev stack. They are dev stack nodes. So I'm using one of the controller nodes, the OpenDaylight controller. Other is a compute. And in dev stack, we know that controller also is a compute node. So like I have 2 compute nodes, one being controller, other being the raw compute node. And I have the OpenDaylight running in a separate VM, the native Mac.
Each of these boxes is a VM?
These are the VM, yeah. This is the VM, and they are connected using a management port, right? And we also have a data network here. So they are connected this way. and of course OVS is running in both these compute nodes. Once things are set up, you'll see that the compute nodes will connect to the ODL using OVSDB connection. Okay, so we have both passive and active support on the OpenDaylight, like what do you have in OVS, right? We had this discussion yesterday, how to do the passive and active, but currently in the dev stack, what they're doing is they are doing the active connection from OVSDB towards the ODL. So we will configure the OVSDB to say that, hey, this is the ODL, connect yourself to do the OVSDB connection to that. So you'll see that there will be OVSDB connection between.
Shouldn't that be done over the management network?
It is management network. Over management network, yeah. So all the items, if you look at the local.conf, we will configure all the management networks and whatnot, right? So there will be one connection from each compute nodes towards ODL on port 640, which we use today as default for OVSDB. Okay. So now the ODL becomes the OVSDB client, right? Because the OVSDB server is running here, and we become the OVSDB client for this management, for managing these connections. So what OpenDaylight does is, the moment we get a connection from these compute nodes, we in turn, since we do the get schema, we do all the basic mechanisms that we're supposed to do on OVSDB, where we do get schema, we get all the schemas, and then we know exactly which table belongs to which one, we know which version that OVSDB that we are running on. And the first thing we do is set up the OpenFlow controller, because OpenDaylight is a multi-protocol controller. So we go back, right, and set up the controller information on all the existing bridges. So if you have a bridge, typically in an OpenStack dev stack scenario, VRNet is created by a priori, right? So we go back and set the controller information on the bridge that is already created. So you see that the moment you set the controller information, there will be a controller setup. So you will see one more connection from these switches for the OpenFlow connection. So now the ODL will have 4 connections, two connections for each devices. One for OVSDB, one for OpenFlow. And we create more bridges, you'll see more OpenFlow connections being spawned automatically. So that's what is being done today. This is the setup that we have, and we'll start on the demo. You'll start seeing that as and when I create new tenants, before even creating tenants, what I do is we create tenants here. With OpenFlow 1.3, we have configuration. We can configure either 1.3 or 1.0 on the OpenDaylight. If it is 1.3, we create one tunnel between the compute nodes. VXLAN or GRE, it works naturally. But if it is OpenFlow 1.0, we create tunnel per tenant, because 1.0 doesn't support the. Yeah, we can't tunnel ID rate in 1.0. So we create per tunnel per tenant across the compute node. This is really bad, but we made it work that way. So we use the OVSDB connection to create VXLAN tunnels, GRE tunnels, configure the port, interface, everything. So those all works great. And we did one thing here where
I was curious whether you configure tunnel monitoring and what your experience is with that.
So yeah, we haven't implemented tunnel monitoring yet. Okay. The one thing that we observed, the problem is in OpenStack, we don't know the tunnel endpoint. The tunnel endpoint is IP address to endpoint, so we have to know a priori what is the tunnel endpoint for these compute nodes. In OpenStack, in DevStack at least, we have this configuring a local IP that we can read if you have an agent. But since we don't have an agent in an OVS agent setup, right? Since we have a local thing running there, we can communicate the IP address back. But since we don't have ours, the agentless deployment, where we don't have OVS agent running on these compute nodes. Since the OVSDB is there, we decided to use the other config in the OpenSwitch table, and other config will push the local IP information to the dev stack, and on the OVSDB channel we pick the other config and use it as the tunnel endpoint.
Is the endpoint likely to be different from the IP address that OVS DB can
because
from?
this is a management connection with the data connection, right? So typically channel endpoints, they have the data paths and manage. So that's why we don't want to assume that. Right? So that's what we do. Yeah. So we use the local IP configuration from the other config. And if I do a sudo OVSDB, so we use the external IDs. So the external ID is today used by the Neutron today to populate the information like the VM IDs and port IDs. So we didn't want to mess with that. So we went with the other config. But yeah, if you suggest the external ID,
usually other config is used to configure the vSwitch, like things that we didn't want to give their own column, and then the external IDs we usually use as information that's provided to the controller.
Right.
Additional information.
The external IDs is meant to be much more like a scratchpad than other config.
Oh, okay.
You probably won't hurt anything by using other config, as long as you don't accidentally use one of them that we've defined.
It's more just the convention that we use.
Well, then we'll change. We can always go to the external ID.
It won't hurt anything, most likely, to use other config.
All right. So if I do a sudo dump, you can see that we use the other config here right here. Right. So since we get information, we configure the local IP in there, and from there we pull it. Since we don't have, the only reason we did it is because we don't have an agent running on the compute nodes. It's purely agentless configuration. When you say agentless, OVS is running, of course. You don't have an OVS Neutron agent.
That name actually sounds kind of familiar. I feel like we've defined something called local IP.
Oh, it's the same name, yeah. I stole the name from the OVS config, some config file, and use the same name here. It's called local IP.
Oh, okay.
Yeah, I mean, I ripped up a lot of things from existing things, right?
It's better to reuse when you can.
Exactly, yeah. And I don't. Yeah, so now as you can see here, the dev stack is stacked. So we have both the VMs running here, and there's a lot of messages here. But if I do a print nodes, you see that the OpenDaylight has connections for multiple switches here. We have always connection here, and we have the open connection as well. It's all established. It's all ready to go actually. I can show the code in the OpenFlow since we are doing Hackfest here. Like, it's better to show the code. It's much fun that way. As you can see here, the OpenStack is an application I was telling, right? It's a stacked application. We have OVSDB Neutron, and then we have the OVSDB plugin layer. This is what I'm interested in because this is exactly what talks OVSDB to the switch. The application like OVSDB Neutron makes use of this layer, the plugin layer, to do like create tunnels, create the extant ports. Everything is done using this library. That will be called the OVSDB library, which we had to rename. We discussed about the renaming, but we took the renaming to the TSC, and there's a big hoopla around that. I said, okay.
I was telling him at dinner last night about the hoopla.
No, I said, forget about it. I don't want to deal with the renaming now.
Well, yeah. I mean, if we have an objection, it's really just that. I mean, in public, like on Twitter, it kept being referred to as just OVSDB, and that was really confusing.
Right.
So, I mean, if you just said OVSDB plugin, that would be
sure.
That would make it clear. I'm not trying to make you change stuff in your source code. That would be a level beyond.
So if look at here, right? The OVSDB is like Java or OpenDaylight OVSDB, but we call it OVSDB everywhere, right?
Oh, yeah.
I can see that.
It's pretty clear in this context that it's part of OpenDaylight.
Right. So as you can see here, right? The library layer here, we have whatever we see in the RFC 7047. We see everything, all the code done here. The JSON RPC, we have the message structures, we have the notation like the condition, function, mutation, muter. Everything is being defined here. And the one that I was talking to you yesterday about the map and set, this is where we kind of convert them into map or set based on the our own custom JSON parsing mechanism here. And so what we have today is, if you look at the code, we have hard-coded we have static binding of the bridges and capabilities. Look at the OVSDB tables today. All the tables defined statically here, like the bridge, capability, controller, and everything. And this is when we saw the OVSDB 1.5 had capability, but later it was removed. And then it threw alarm right away saying, hey, you guys removed the capabilities not part of 1.11, right? That's how we noticed that.
Do you want us to add them back?
No. We don't use it. We don't use it. And what we're doing now is, since it's all static in nature, we are having this difficulty of since OpenDaylight is a generic controller, right. we are having a lot of requests from other vendors, other folks about supporting hardware meetup schemas and other schemas, right?
Are they both static and handwritten?
Yeah, we were doing static handwritten. Now we are removing everything. In fact, Ashwin is here. Ashwin is helping code that, where we are moving away from static and making everything dynamic. So we are removing all this class files, Java files, and making dynamic. And the applications which is running on top of this layer will have to use metadata to access data now. So they cannot just say bridge.create bridge. Rather, they will say transact, create, add, and then say bridge table and whatnot. It's a bit more cumbersome, but that's the most flexible that we can provide. Yeah. And we are doing that. So this is a fixed one, and as you can see here, IPFix is a new one is added on 1. So now we added on IPFix as well here. So it's kind of getting complicated for us from a controller standpoint. We don't want to manage tables created on OVS every single time, so we are making dynamic completely.
What do the different logos by those files, or different icons by those files mean?
Oh no, this is, the Eclipse has this way to say what file I changed. In this repo I changed some few code. Okay. So the IPFix and bridge I have changed, modified it now, and that's why I use it.
Makes sense.
And if you are curious to know what I changed, you can see it here as well. There you go. So the IPFix is being added new by one of the requests came along. So we just added the IPFix table, and as you can see here, we incorrectly wrote it as an integer, but actually it's a set. So I had to change the. Okay. This is the problem with statically defining the schemas in the code. So if the schema changes, I need to come back and change the code here. Right. So we are changing completely down that. It's all being changed.
So when you say you support 1.5, automatically the outbound will also be 1.5 support.
I think that he means Open vSwitch 1.5 when he mentioned 1.5.
Yeah, Open vSwitch. Yeah.
That's different from the OpenFlow protocol version,
Okay.
which I think maybe you're talking about.
Open vSwitch 1.5?
Schema is different version. And schema version.
That's definitely pretty old, right? I was going to say Open vSwitch 1.5.
Oh no, when we started, we started 1.5. I remember that. When we started, capability was there. That's when we added it, and then it was removed to 1.9. Something like that. Right?
I think one of the greatest injustices is the fact that everyone starts with Ubuntu 12.04, which has OVS 1.4, and then, how many times I have to tell people, why are you using that ancient version of OVS?
I think Mininet has a version that's that old also.
Does it also have an old one? Yeah, I think so.
Yeah. So this is a change that is coming now, and after this, I think the library layer will at least look much more stable. We don't want to change it ever after that, hopefully. Yeah. So it's been pretty reasonably working well for us so far.
So feel free to report bugs if we do unintentionally make backward incompatible changes to the schema, because we don't do that normally.
Sure, definitely, yeah. If I used capability, we would have definitely this is changing, right? But we didn't use capability at all.
Yeah. So
we didn't have any problems. And so far, we didn't see any incompatible change between versions. Yeah, okay. And as I said, right, the problem that we are facing in OpenDaylight is that since we'll be talking to multiple switches at the same time, we have to make sure that we have multi versions of cable as well. Right. So yeah, that's an important factor for us. So that is it. That's the overall code walkthrough on what we have done with OVS DB. And the OVS DB Neutron, this is useful for many folks here who are interested in that. The OVS DB Neutron, in OpenDaylight is based on various bundles. Java bundles are isolated modules where every bundle can be dynamically loaded and unloaded in the running system. You don't have to bring down a controller at all for if you want to do it. It's very useful. Neutron is one such bundle where it is the application that is going to take all the Neutron APIs and make use of the OVS DB plugins, like creating a VXLAN port, for example, right? So we use all those the plugin APIs from this bundle, and let me show this one. So if you look at OVS 1.3, if you are running OpenFlow 1.3, we use different things. We use 1.0, we do different things because of the nature of the protocol itself. For example, here, so this function is called the add tunnel port. What you're doing is you're actually adding a tunnel here using the there you go, right? There you go. So using an update, the OSDB's update row mechanism, we create this interface and we add this local IP remote IP key equal to flow, set it up, and it creates a tunnel for us. So it's pretty awesome. And the update row is a function that is provided by the library, and then we are done. We never face any bugs so far, at least on the protocol side or on the OpenDaylight side. It works very stable so far, I would say.
Okay, great.
Yeah, it's really awesome.
The database is one of the best tested parts. I rarely get bug reports on it.
It's absolutely, to me, it's zero so far. Really well done there.
How much code is there in for maintaining the OVS DB, the library that you have? Is that, obviously it makes sense to have it in OpenDaylight. I was just curious, if it makes sense to, for OVS to have something like that, we have Python bindings, would it make sense for OVS to have
Java bindings, right?
Yeah, Java bindings.
So in fact, the plan that we have for that, for hydrogen, what it is, we kind of made it tied up with OpenDaylight.
Yeah.
But for helium, we have the next release. We have this plan to move this OVS DB library completely isolated.
Okay.
Meaning it's like a library, like a binding, which anybody can use it. You don't have to be part of OpenDaylight.
Sure.
It can be used by anybody.
Yeah, that makes sense. Great.
Yeah. So that's the plan we are working towards. And it'll be dynamic where you don't have to be specific to a given version of OVS DB. It will just work for any version, any schema.
Okay, yeah, so it'll be generic, so it could work with the VTEP schema.
VTEP schema as well.
Wow, that'd be awesome.
That's exactly what we're working on now.
Okay, yeah, that'd be great.
Yeah. And it will be part of the OpenDaylight's repo, but can work anywhere. It's like a
great.
Right, it's like that. So that is that's a high level code. If somebody wants any specific question on the code, I can give a walkthrough of that.
Well, when that's available, why don't you drop us a note so that we can include a link to it and some information in the OVS repo? Oh,
Absolutely. In fact, we are developing now, and what is available, we will get it for sure.
Great.
Absolutely. And if you look at all the, let me go back to my OpenStack stuff here. So OpenStack is up with the connection to the.
Can I interrupt with a quick question? I'm sorry.
Yes, Tom, go on.
I noticed that on the top it said OF13, but it looked like that was OVSDB command you were showing.
Right. So we are looking at OVSDB, but if you look at the Neutron, the one you're looking at here is the Neutron application bundle, right? The Neutron application bundle makes use of both OVSDB and OpenFlow 1.3, like this picture was representing here. So the plugin makes use of OVSDB for creating and managing the VXLAN and the overlay tunnels. It also uses OpenFlow 1.3 or 1.0 based on deployment for managing the flow rules. So the application makes use of both of them. So they can use the OVSDB library for tunnel management and OpenFlow 1.3 for flow management.
But I think.
Oh, so we're looking at the Neutron application on the top of the stack right now.
Right. I mean, I was going back and forth between.
I was just going to point out, it's really.
Sorry. Thank you.
Two different strategies for implementing based on whether you're talking to a 1.0 capable or 1.3 capable node.
Right.
And so it's confusing because it's an OVSDB, but it's really a strategy for tunnel.
Correct. Yeah.
Tunnel.
So since we talk about application can decide to use any plugin they want to. So the question that you asked yesterday, right? Same thing. If you look at the OpenFlow 1.3 provider manager, you'll see that it uses both OVSDB for managing tunnels and if you look at the tunnel flood out, for example, you'll see that it uses the flow builder of OpenFlow 1.3 and program the flows. So it's straightforward. You can just take a look at this one. Right?
We're going to lose power soon. You can try this, but I'm not sure if my air will power yours, but
it will, but it's very slow, but.
Okay, all right. Just so you don't
Thank you.
die.
Thanks. That's a good idea. So let me do OVS, VSCTL. Now I can see that. So as you can see here, right? So this is done by the controller. The controller has created the VXLAN tunnels between the compute node and the controller node, because the controller node has the DHCP client agent, right? So it has to create. By default, we create one because we need to have a DHCP agent. So by default, we create this tunnel between all compute nodes and a controller node. So that's exactly what you're seeing here. And when you go to the compute node, you see the other endpoint as well, right? So this itself shows that the controller works in tandem with the OVS, using OVSDB to create the VXLAN tunnels, orchestrated based on single click, right? So you don't have to do any special configuration. Automatically, it does everything for you. And the local IP, remote IP comes from various nodes, right? So local IP of every single node becomes the remote IP for the subsequent box to connect to the VXLAN. That's why local IP is important configuration that we have to do.
So it creates two ports here, right? One port is on the management interface BRN, and another is a VXLAN interface. There's a two port on the bridge, right? Port BRInt and VXLAN.
Yeah.
This is the port in BRInt, port BRInt is an interface.
Yeah. So let me explain, right? In OpenFlow 1.3, yesterday we were discussing about it. We decided to use one bridge and using multiple tables for doing all the flow forwarding, right? So all the tunnels get terminated in the BRInt itself. In 1.0, we had this multiple bit support where BRInt will terminate all the local VM forwarding, and we made it normal forwarding there. But we created a tunnel called BR tunnel bridge, and that's where we terminate all the tunnel ports. Okay. But in 1.3 we decided to use just one bridge. We didn't see a need for multiple bridges, so we just had one bridge. Okay, that's why you won't see multiple bridges. You see only one bridge called BRInt. And if you spawn a VM, you see a tap port being created here, same bridge, and also tunnel is also part of the same bridge.
Okay.
But we won't flood. You will never see a flooding of packet going everywhere. If you're worried about that, because if you look at the OFCTL command. There you go, right? So every single flow is being hand coded. You don't have normal forwarding at all here, right? You'll see that local VM traffic will be forwarded using, regularly using MAC-based forwarding, and tunnel will be forwarded. You'll see that every single flow is being hand coded, because in a Neutron, since we know exactly which VM resides where, it's all proactively programmed. And default is dropped. We don't default punt to controller. Default is dropped on the host. Okay, so it's a strictly a proactive model. There's no reactivity at all, at least from switch to the controller. But DP will be reactive in that nature, right? That's fine. But
so your table 0, 10, 20, what date?
Yeah.
Each one is for what?
So this is OpenDaylight controller's way of representing the tables. So what we have done is table 0 here. Table 0 is used for, table 0 is the default table, right? Where every traffic coming in will hit table 0. Whether it is a VM generated locally on the compute node or traffic coming over the overhead node. Doesn't matter, right? So if you look at here, this is where we do the classification. So we call it the classification table. We classify the traffic based on whether it is locally generated or a remote one. Table 10 we call the egress table, where traffic which has to go out of the compute node towards the other one, we use the table. Table 20 we use it today for the egress from tunnel towards the VM. Right?
The table 20 basically replaces the VR2.
Exactly, right? So multiple tables takes care of it. One cool thing about multiple tables, I really like it, is it's flexible, of course, right? We have 256 tables. So now Brent is actually working on security features now. So we are going to have one more table for security, and we will have more tables for various purposes, right? So maybe load balance will have a table, right? So we can add features, use tables, and then have a intelligent way to put them together. So it's very useful.
Have you thought about how you'll implement the security features? I assume you're talking about like firewall rules.
Right. Yeah. So that's been worked on. In fact, we had a discussion yesterday. It's not been completed yet, but definitely we're going to have one table. We're not going to have tables for protocol. We're going to have one table for features. But typically, I come from a different background. Before OpenDaylight, right, I was coming from a Cat6K kind of background, hardware background. So there we had this tables, of course. We had the pipelines, egress pipeline, and based on the pipeline, we'll have hit various tables. So if you look at ACLs, right, we'll have port-based ACLs, then we'll have the layer 3 ACLs, ingress ACL, and then we'll have egress ACL as well. So we might design something similar to that, where we might have pipelines, and we might decide that tables from 0 to 100 is, or 0 to 50 could be an ingress pipeline, 50 to 100 could be an egress pipeline, and we might change them based on that.
Yeah, I guess I meant the actual mechanism for doing like TCP port-based firewall rules.
Yeah.
You know, like in terms of doing it in such a way that you might get reasonable performance. I don't know if you thought about that or not.
Yeah, I mean that's the decision we are having now. The security rules are we follow the Neutron guidelines. Neutron has this security policy feature. So whatever is supported there, we will support here. So they have this tuple based security policy features, right? So we will support exactly the same way. And even for that, we need the ingress and egress pipeline, because the reverse traffic needs to be accounted as well, right? Yeah, so we are doing that. That code is not there here, so that's been worked on. And as you can see here, the interesting part is, from an overlay standpoint, the interesting part is here actually, where you can see that we set the tunnel ID here on the flow, and when you look at the OVS VSCTL, you see that the key is flow. That's why we're able to achieve the not so scary scaling of 1.0, where we need per tunnel per tenant.
Have you found a need to visit a table more than once, Jim?
Not yet, but we will soon. I think we'll see it. Yeah. Today, no. Today is the implementation you see today, right? It's pure L2 forwarding. That's it. We don't have anything other than that. L2 LC, of course, from the gateway standpoint, but there's no interesting features that's been added on top. It's a pure, simple overlay concept.
Okay.
Once we add more services, I'm pretty sure you're going to end up in a scenario of recirculating our account. Okay. We might end up, let's see. Back in my days when I was working for previous days, right? The recirc is a very common scenario for multicasting. If you want to do any sort of multicast, you will end up, if you want to multicast, you send over a tunnel, specific tunnel. So there will be a replication table where it goes, traffic goes there, it replicates, and the traffic comes back, and does another lookup for sending over a given tunnel. So we might end up doing something similar if there's a need. But in this case, we don't have to, because it's a very flexible table mechanism where we can dedicate one table for multicast, and we can do a next lookup based on that. So we are not forced to come back, but I think we might have to sometimes.
Okay. I only bring it up because these days there's a few ways to do this in OpenFlow approved manners that we can talk about if you have a need for recirculation.
Oh, is there a way in OpenFlow?
There's a couple of ways that are sort of sanctioned by the standards, and we don't implement them yet, but we could. So let's talk about it.
Sure.
If you need to do it.
No need, but I'm more interested. Once we know it's there, we might think of something cool to do. Yeah. So this is a high-level picture of what we have done and how it works. And so far, we've been very happy with OVS. I have to say, because we didn't have any problem with OVS itself, and so far it's been stellar. Thanks to you guys for that.
So one thing I noticed here is what do you have like a minimum OVS version that you support? One thing here jumps out at me is would not be supported on old enough OVS versions, and that is that your port name here for the VXLAN port, I think that's longer than the 16 characters that Linux supports as an interface name. It ought to work with 2.0, and I think back to maybe 110 or so, because for tunnels on those versions, we don't actually create a Linux port by that name, but if you go back far enough, it'll try to, and that'll fail.
If we're not wrong, I mean, we said 111, right?
Well, I think we said that it was 110. I think that's what the
110 or 111.
I think that change happened in 110. Jesse might remember better.
Yeah. Yeah, that sounds about right.
I mean, I don't think, it's, oh, sorry, go ahead.
I was gonna say, probably it's not a good idea to rely on that. I mean, it's kind of way internal implementation detail.
Yeah, so the thing is, what we're doing now is, today we have an internal assumption today on versions. With the change that is coming, we are going to put the ball on applications to decide which version they want to use, because a lot of assumptions is being made today, like for example, key equals flow, right? Right, there's a lot of assumption is there, is supported there, but it may not be supported. So we are trying to have the version, parse the version information out, and parse the applications to say which version they really want to do. And based on the version, we might do the checking and then allow or disallow based on the functions.
Sure.
Yeah. Today there's a lot of options like this. And the work that we did for OVSDB and OpenFlow with Power Neutron, we did in very less time. We didn't have much time to even think it through.
Okay.
So in less than like 2-3 months, maybe we had everything done. So it's pretty interesting so far. So that is it, guys. You want me to launch a VM and everything to show it's going to be similar though?
Is there an interesting demo or just
No.
just showing?
No, it's not interesting for at least this crowd here because we're interested in the OVSDB. For those who are really interested in, for example, for Vinay and others who are customers who want to see, hey, VM can be launched and traffic can forward, it's useful for them.
Okay, I've seen a lot of demos.
Yeah.
Ping works, ping doesn't work.
Yeah, exactly. It's going to be similar, which I don't want to do.
All right.
All right. So,
Thank you.
cheers. Thanks.
That was good.
Sure. So Kyle, stop recording.
I'll stop.
Hey, thanks guys on the